Okay, so yesterday we looked at what a typical data engineer would do, how we can consume data from a pipeline. Yesterday we used the weather API to consume weather data and then looked at the forecast all within Databricks. We also understood that you can organize your workspace and keep it much more structured so that you track everything that you're doing. Within Databricks, it's a single platform for everything, right? So you can have your data warehouse, your OLTP, which is your relational databases. You can have your data pipelines themselves, and then you can also do machine learning and AI on top of it. So all in one platform for data engineers to use. Most of the time, you will be working with notebooks, and when you have data coming in, you save it into a database. Now, Databricks has an inherent data solution that they call the Unity Catalog. The Unity Catalog allows you to structure your data using lakehouse architecture. And a lakehouse architecture essentially means that you have storage of the data as well as warehouse or a database on top of that data. And so that architecture that is built into Databricks makes it very, very unique. Now, the Unity Catalog is very, very popular. It's ubiquitous among data engineers. That is where you structure and keep your data. So as you can see on my screen, if you go to the left side, there is a catalog over there. And then over there, I've created 3 catalogs. So we have a bronze catalog, a silver catalog, and a gold catalog. Now, this is the industry standard when it comes to organizing, structuring, and then making your data available for the data scientists, the analysts, and folks who will come in there to consume the data. We call it the medallion architecture. So medallion architecture essentially means that you have your first layer, which is bronze, which is your raw or staging layer. And then there's a middle layer where you do your transformations and joins and calculated columns, and then you clean the data. And then the final gold layer, which is essentially your data mats, where the data is given out to the machine learning guys, the data science guys, the AI guys, the analysts. Anybody who wants to consume the data will consume it from the gold. You, the data engineer, would bring in the data first. You keep it as it is in the bronze or the raw layer. And then you do some cleaning and organization of the data, and you keep it in the silver layer. And then when all that cleaning, everything is done, then you ship it to the gold layer, which is your final state of the data for reports, AI, machine learning, data science stuff. So this is how the industry medallion architecture is structured. Now, it's very, very important for you to become abreast with some of the terms that I'm using. And so you will hear me repeat them over and over and over and over and over for you to get comfortable and be able to use it on a day-to-day basis. Behind the scenes, it structures the data in what we call a delta table. We'll get into it, but essentially that is where your lakehouse architecture is coming from. The delta table within this catalog, think of this as a database, and then within that you have another layer of organization. I've created one. This is called a schema. A schema is a group of related tables all under one umbrella. So I've created an Alpha Vantage schema. Alpha Vantage is our stock API that we talked about at the beginning of the class. So I've created that. It has default schemas, which is these ones. But any schema that you create under any of the catalogs, you will see it here. So I've created Alpha Vantage schema. You can create as many schemas as possible within the catalog. Now, over here, I've built a pipeline to bring in S&P 500, all the tickets that are in there, all the stock prices over the past 30 years. And that is where the exciting part is coming from. So I, the data engineer, has built this pipeline, brought in all the data for S&P 500 tickets using Alpha Vantage API into this table. Now, that is what the data engineer would do. But of course, you also have to understand that once the data comes in, you should be able to query the data. Now, querying the data is the exciting part, right? If you look at this layout, you would see that it is related to our introductory class where we have the cabinet system of storing files. In the cabinet system, you have a large cabinet with drawers. So maybe there are 5 or 3 drawers in there. So this is a cabinet. and then you take each drawer. So this is one of the drawers in there. In the drawer, there are folders, so you can treat this as a folder. And then within the folder, there are files in that folder. So similar thinking, similar structure, but then it's being used in the database world. So if you come into the pipeline that I wrote to bring in that data for S&P 500, push the data into the Unity catalog table. So if I run this, you will see that I did some querying on top of the data, and then you can see that for every ticker we have, these are the unique date counts, how many years that date count converts into. So about 30 years for each ticker in a table, all within the S&P 500. So this is a typical data engineering pipeline that I've built. I can run it once to get everything over the past 30 years. I can schedule it to get incrementals. Now, incrementals are what changes you bring in. So if you know that if I run it today, I'll get all the stock prices up till today or maybe yesterday. Now, on Monday, we'll get new stock prices for today. On Tuesday, we'll get new stock prices for Monday. So those changes, you have to schedule this pipeline to bring in. And Databricks makes it very simple. If you see here, there's a schedule here. So if you click on the schedule, I can say run this schedule every day. And once I save it, it will run the script every day. And I have to make sure the script is bringing in the deltas or the changes, only the changes. Because if I run it up to today, I only want the changes from maybe tomorrow, Tuesday, ongoing. So it will bring in daily changes into my historical table for the stock prices. Very, very exciting because we are dealing with real-time live stock data coming from Alpha Vantage. And Alpha Vantage is an API that allows you to do that. So if you look at it, it gives you stock market data, and you get historical stock market data, you get all the indices, you even be able to go over some market news and be able to do some agent work with it. So Alpha Vantage is pretty cool, has all that data. If you are interested in stocks, Alpha Vantage is what I use to grab all that historical data for stocks. Now, don't worry about this part. Once we start getting into Python, you will know how to write Python scripts and be able to use and write your own pipelines. For today, I want us to focus on querying the data. So if we have the data in a table, what do we do when we have a data in a table? So the data is here within the Alpha Vantage schema. This is the table. We want to query the data in the table. And so that brings us to our introduction to SQL. So when you have data structured in a table or data within a table in a database, what you do is you query that data. How do you query that data? You use a query language called SQL. It's SQL, but we pronounce it as SQL. That is how we pronounce it in the industry, right? We say SQL. That's how we pronounce it. But it's SQL, Structured Query Language. We pronounce it as SQL. Now, the way I like to approach this, I keep it very, very high level so that you know what is going on at every point in time. If you have data in a table, what actions can you take? Or if you have a database, what actions can you take? I want you to put in the comments if you have data in a table or if you have a database, or if you want to think of the good old days cabinet system. So that cabinet that is there with the drawers and the folders and the files in the folders, what can we do? We can add new data. We can add new folders or we can add new data depending on what you're thinking of. So I would say add data, add more data, right? So we are looking at all the actions we can take. Add more data. What else can we do? I want you to put in the comments. What else can we do? We can add. What else can we do?
Delete.
Say that again.
Delete.
Yeah, we can remove or delete data. What else?
Group by.
Say that again.
Group by.
Yeah, we can organize the data So edit or modify. So yep. So we can update the data. And then we can just see, right, the data. Take a look. Right. So these are really the actions we can take when we are really dealing with the data. So that's how you you have to think about it. You can just see the data. I just want to see it, right? You can also take a look, and not just take a look, but you want to analyze the data. So you want to analyze the data. So these are the actions at a high level that you can take. Now, if you are building this language, of course, yes, you can query it, which is see the data, query, see the data. Of course, you want specific ways of doing that. So, okay, so we have folks who are joining. Let me add them. So if you are building SQL and you are the guy who introduced this SQL or SQL or structured query language, these are your high level. This is where you start from. What actions can you take? And then once you know these actions, you can define how you want that done. So let's take the simple scenario of you just want to see the data. Now, within the language, they have keywords, right? So the keywords and the structure is what you follow. And once you do it over and over and over, it becomes second nature. So whoever defines SQL, he came up with select as a keyword. And he says, if you want to see everything, you can select star from, in our case, we have our catalog, Alpha Vantage, and then the historical 30-year table. So this is your full table path within the unit catalog. So this is the catalog, this is the schema, this is the table. That hierarchical structure that I showed you earlier. So if you do a select star from this, sometimes in the enterprise environment, that table will have so much data. Just select everything and then you consume the memory, and it's bad practice. So you can limit it to just the top 1,000, just so you can see what's in there. You just want to see 1,000 records from that table. So you say limit 1,000. So select star from table name limit. 1,000 means that show me only 1,000 records from that table. That way, if the table has 1 trillion records, 1 billion records, you don't show all of them because that will overload your memory. So let's just take a look at just 1,000 records from this table. And one thing I like about Databricks is it's so beautiful. So as you can see, it's showing me at least some of the tickets. In this case, ABT is a stock. And these are live, real-time, live stock price data, historical stock price data. And so if you look at ABT, you can Google what ABT stands for. On this date, which is June 12, which was essentially Friday, this was the stock price for that stock. If you see, it started at 89, went as high as 90, came down to 87, and on the day it closed. So that's the closing stock price. So there's the final stock price for that date. And it closed at 88.18. And you see the volumes that were traded. So this is ABT stock price for June 12th, just Friday. Now you'll see that every single date is here, all the way down. And that tells you all the stock prices for every single day within this table, which is pretty cool, right? You can do so much with this information within Databricks. You can do so much with it. And so questions at this point. So your initial thing, you just want to see the data. The data engineer has already built the pipeline, and the data is within a table within the Unity catalog on Databricks. You use SQL to query that data. So if you query it, this is what you see. This is what you see. Now, so you want to see the data, this is how you do it. First, know the name of the table that you are querying from, and then select star from that table, then you limit it to 1,000. You can limit it to 100, 10, 5, 6, whatever. I just use 1,000 just to see enough. And then you take a look at the data. This, you're just taking a look at the data. Now, you can also, if you want to see, so if you look at this, only ABT ticker is shown. There's a way that you can choose randomly 1,000 records from that table. So if you do select star from that and you limit by ordering randomly, you can get random 1,000 records from that table. That way you can get different tickets and different dates, and then you can take a look at it. So over here, you can see that now we have different tickets, different dates, and that tells us. So if you see, this is very interesting. This is NVIDIA in 2015. NVIDIA in 2015, this was the stock price. If you knew this, you had this information, and you knew based off of some signals that NVIDIA was going to be the most valuable stock at some point in 2026. You buy this, and then 2026 you profit. Now, these are the random data. That way, you take a look at the data, you assess it, you understand what is going on, and it makes sense to you. So you can select from the table. So this select statement is very important. Look at the order. Star means that all columns. You can also select specific columns from the table. So in this case, let's select maybe ticker. So date, ticker, close. So the columns that I want are the closing stock price, the date. You can also give it what we call an alias. So it means you're renaming this column as trading date. You can rename ticker as symbol. You can rename this as closing stock price. And then you just want to see just some of those records. But of course, you want them shown randomly. So as you can see, I select the statement that I want to run this, then I hit run, and it runs just that statement for me. Now, so you see this, it selected only the columns that I wanted, and then giving it the aliases, which is the renaming that I gave in there, and then randomly showing me some of those records. So this is 2023, NVIDIA that was 16 in 2015, it's now 278. So if you had that information, and if you had analyzed this stock way back and you had that information that NVIDIA was going to go high, this would have been extremely massive profits for you. So this is how you take a look at the data. This is how you query and just see the data for your own understanding and analysis of the data. So that's the first definition. Let's take a look at the data. So we run what we call select statements. So we've selected from the table. We've also selected specific columns and given them new names. So as you can see, is column, new name, comma, column, new name, comma, close as closing price. So the last one here, there's no comma. We only use the comma to separate them. And then from, so select columns from the table. Where's the table coming from? The table is coming from the Unity catalog all the way to the table name. So this is actually the table name that are inside this Unity catalog and schema. So this is a table name that you are using. And we are saying just limit it to 1,000 records. The more you do, the more it gets very familiar with you. When it starts, you just have to build muscle memory around it and type and do it. Now, what else can you do? You can add more data. You can remove data. You can update the data. You can see the data, which is what we've done. You can also analyze the data. So if you want to add more data, say we want to create so let's create a table. Just like the cabinet, drawer, folder, file approach, we can create a table within this same catalog and schema. So if I want to create a table called tickets, which essentially will give me all the tickets and their description. This is how you do it. So you say create table tickets, and it makes sense to specify the full path in here. So that this is your catalog, this is your schema, this is your table name. This is a column, this is a column. So I can say or let's just say details. This is the column called ticker, and this is the data type. This is a column called details, and this is the data type. And the data type tells us whether this is a number, a string, a character, varchar, floating number, integer, decimal. So this tells us what it is. We can create a simple table like this, and it will create it within the Unity catalog, and we can take a look at it. So let's run that and see. Let's run that and see. You will find that when you create this table, it will appear within the catalog. So it says OK, which means table creation has completed. If we come into our catalog, we should see that table. So let's take a look. Let's take a look within our catalog, which is on the left side. You come and you go into bronze, alpha vantage. This is the table that we created, tickets. So this was the table that our data engineer brought in. We've created this table, tickets. Now, of course, when you create the table, you can also decide you want to see it. Let's see what's in tickets. Let's see what's in tickets. And what do you do? We've already answered that question. You know how to do that. We say select star from tickets. We just created a table, so we don't expect it to have anything. It will just show us. It will just show us the ticker and the details because we don't have any data in the table. We've created it, but we don't have any data. So we can add data into the table. Let's add data into the table. Tickets. And by definition, SQL allows you to do what we call insert into the tickets. So this, I can insert data into the tickets, essentially. Now, as you can see, let me keep it all the way up to this point. Okay. As you can see, let me organize it so it makes sense for you. Yeah, this is fine. Great. As you can see, we are inserting into tickets. Now, tickets has the column ticker and details. So these are the columns or the table headers within the tickets table. And we are inserting these values. So the syntax here is specify the columns that you want to insert into. Insert into what? Table name, the columns of the table, and then the values. The values you want to go into the table. So in this case, I'm just adding just these three and these few values. AAPL, Google, Amazon, FD, Netflix, Tesla, Nvidia, PayPal, Alibaba, and Google. These are the tickers that I'm adding into the table tickers. So if I run this, I expect it to add these records into the table. And so it will tell you we've added 10 records into the table. If we go back here and we run select, now we see the table with the 10 records. Very beautiful. Now, because we created a table, created it, we took a look at it, there was nothing, we added data. And now if we come back and we take a look, we see the data that we've added. So every single action that you can do can be done, all of this here can be done with SQL. And it is imperative that you practice and be able to write this SQL script. The more you do it, the more it becomes easy for you and it's at your fingertips. So what I do is, at the end of the class, I'll give you a SQL assignment. You have to come in here and then at least write some basic SQL to achieve that. Questions? Questions before I proceed? Questions? Questions? If you don't want to talk, you can put it in the chat and we'll take it from there. All right.
I have a question.
Yeah, go ahead.
So every time you're writing, like select, or you're selected from a table, a schema, and you have to put the dots between them, or can you do underscore too?
Yes. So in this case, the dot separates them. So if you look at this, this is essentially, this is, you see bronze, right? This is alpha vantage, and this is the table. So if you come here and you look at the catalog, that is how it is expressed. So this is a hierarchical structure within the catalog. So you see the left side when you click catalog, this is the catalog, you see bronze. Under it, we have this schema, alpha vantage. Under it, we have this table, S&P 500 historical 30-year. So when you are, it's essentially telling you that this dot that dot that, which says that this is a child of this, and this is a child of this. So this is the parent, this is the sub, this is the sub. Now, just like a subfolder, right? So you have a folder in there. Within the folder, you have a subfolder. And then within that subfolder, you have files in the folder. Same thing here. You have your table. There is a schema. This sub is called a schema. It is a collection of tables, and then within that, the parent is the catalog itself, which is essentially a database. So the database, if you look at it from the cabinet example, this is your cabinet. You see bronze is your cabinet. Alpha Vantage is your drawer. This is your folder, and within that are the records, which are the files within the folder. So if you open a drawer and you grab a folder, typically you have multiple files in there. So those are the records. And yes, the files in there represent the records in the table. So to access this particular table, you say you see bronze dot alpha vantage dot S&P 500. The name itself has underscores. Not every time will you have underscores. Here, Techers doesn't have any underscore. So always the syntax is this parent dot this dot that, and that is how you access this table. So that's a beautiful question. So that's how come. Yes, it's always a dot.
I'm sorry.
It's always a dot. So this dot that dot that.
And when do you know, like if you're writing a query, when to put a comma instead?
So it's a syntax, right? You will have to. That's why you have to practice, and then you get used to it. It is a structure, just like the English language. I usually use that to explain. So let's get to syntax. So syntax, there you go. So if I say, okay, if I say the quick brown fox jumped over the lazy dog, it makes sense, right? That is the syntax of the English language, right?
Yes.
Okay, so now let me do this. Read that.
It doesn't make sense.
Exactly. So just as the English language has a syntax to it, SQL also has a syntax to it. And that is how I explain it. The SQL has a syntax to it. You just have to follow the syntax. And it comes by doing. So I will teach you all the various keywords, structure, how to use it, style, and everything within SQL. You have to practice over and over, read, use it over and over so you get used to it. So if I'm learning French right now, the same approach, I have to practice before I get used to the French. The same way, SQL, you have to practice, and that's why I'm taking time to explain the syntax behind every action that you can take. So when you want to insert into a table, this is a syntax. It says that write insert into the table. You have to identify the table by going through where it is, because you can have multiple catalogs, which we do. I have multiple schemas, which we do. I have multiple tables. So you have to tell us, where is it? It's inside this catalog. Where in the catalog? Inside the schema. Name of the table. This is the name of the table. Then we correctly identify that this is the table name. So insert into the table name. What columns do you want to insert the data? This column called ticker, the second column called details. What values are you inserting? These are the values. So there's the first value, we are separating them by commas, second value, third value, all the way down to the last value. Now notice that the last value has no comma because we are not separating it from any other one. That tells us that's the end. So once we run this, we insert into the table, and that table has those records as you see here. If you want to see records in a table, the syntax is select all of the columns. Start here says all of the columns from the table. And we did mention that you can select specific columns. So say I want only the sticker or the symbols column, then I have to name it, call it out. So select ticker from table name will show me only the ticker column from the table name, which is very beautiful. So we only see these ones in there. So that is how you select from table name. This is the syntax. Now you want to create a table. This is the syntax. It says use the keyword create table. And what name do you want to give to your table? Where do you want it to live? I want the table to live inside the bronze catalog, this schema. This is the name of my table. These are the columns within my table. And we put them in a nice bracket. And each column is specified what we call a data type. And I did mention that the data types, we have string. Sometimes we call that varchar. You can have int, double, float, decimal. Yes, we even have Boolean, date, timestamp, binary, array, map, struct. All of these are data types that represents the data that you are bringing in. So Boolean will be true or false in this case. Date is a date data type. The timestamp will have an actual time as part of the date. Binary data, an array is a list. A map is sort of a dictionary, and this is an object. So all these are data types that can represent the data. Of course, you know what an integer is. A double is also a number type. A float has more precision. Decimal has specific precision. Boolean is true or false. So depending on what you want to insert, you will specify the data type. In this case, they are both, strings, and that's why you have ticker, which is saying ticker is a string. If you look at what a string are essentially numbers and alphabets and numbers. So mostly alphabets you see here, then you represent it as a string data type. Details, you represent it as a string data type. So if you query only the details here, and you can specify both columns here. So if I say details, I query it, then you will see that both columns are showing. The sticker details is also a string. And what have you. In our initial case here, I do from the table that I generated, you can see that this is a date. The date column is a date data type. Open here is, as you see, is either a decimal or a double or a floating point, most likely a decimal. So these are the data types. So this, of course, this is not an integer, right? Integer will just have single, there's no decimal precision .15, right? So this is floating point numbers. Volume, as you can see, volume is an integer because it doesn't have the .01, .03, those precision after it. So as you can see, this is how the data types are structured. Now, you just have to at least practice. So as part of today's session, before I let you go, I'm going to have you one by one do it. At least query. You have to build that muscle memory. So you go in there and then query this table. You query it, take a look at it, and let's have some fun. You can also query specific ones. So I'm going to do that as a last step before I let you share your screen. So do what we call filtering the data. So we can filter the data to see specific records, right? If I say select, let me just do ticker and then date. So when I do as, I'm giving it an alias date because the column is dates, right? But I'm saying I'm rename this date column as trading dates. And then let's look at the closing stock price as closing price. And then I'm saying that from this table, which is what we are using, where is what you use to filter? So up to this point, you understand that we are selecting these columns from the table. But if you want to filter for a specific, let's get rid of this, we'll come back to that later, for a specific ticker. So let's see NVIDIA, which is very exciting. So we are saying where ticker is NVIDIA. It's saying that filter for only NVIDIA's stock. So we want to see the ticker, we want to see the trading dates, we want to see the closing stock price for NVIDIA. Don't worry about what's down here. This is what we are dealing with. So select columns from table where the column ticker is NVIDIA. This is the syntax for filtering. Now you can also order. So you can say order by closing price in a descending fashion. So if you filter NVIDIA, take the results and order by this column. The column is the closing price. That's what we want in descending, which means that from the highest to the lowest. So if we run this, it will show us everything, all the stock prices for NVIDIA since they split. At some point, they split this into smaller ones. But at least it will show you that closing stock price from the highest all the way to the lowest. So as you can see, it went as high as 1224 in 2024. And if you scroll all the way down, this is showing us only 1,000 records. But if you scroll all the way down, you will see that at some point in 2023, it was 227. And it came all the way up to 1,224. 6 times. So even if you bought NVIDIA in February 15, 2023 for just $200, and you held it for roughly 1 year and some months, you would have multiplied your money by 6. Is what this is. So what I've just done is analyzed the data. After I filtered it to just NVIDIA, I've analyzed the data and I've seen that if I bought in 2023 for just 1 year, for say $10,000, I would have had $60,000 in 1 year. What I've done is I've analyzed the data. And this is how you do it, by filtering the data to a specific stock, say NVIDIA, and then you order by some column. You can order by another column, but it has to make sense for you what you're doing. So we are ordering by closing price in a descending order and saying that, okay, take the closing price and start from the highest all the way down. So what I want you to do is I want you to do the same thing I'm doing so that you build the muscle memory but I'll have you do select statements and we will filter. So I'm going to put this in the chat and then you guys can play with it. You can also do conditions and do logical operations on top of it. So you can say, let's do logical operations. You can do mathematics. You can do everything. Math, or let's say math and logical operations. So you can also take that same ticker and say, so when you say where ticker is NVIDIA, you can add conditions. And maybe closing price is greater than 999. So when I say this, it will filter to NVIDIA and make sure it displays only the records where the closing price was greater than 999. And we can order by the closing price. So this is the format or the syntax when you're writing select statements. So you have select from where and order by. So select from where, order by. So these conditions, this is the order. You cannot mess it up and bring order by first before you write where. Where has to come before order by. So this order of select from where order by is very important that you follow that same order. That is the syntax of SQL. And as you do it, you get used to it. It becomes second nature. It's one of the easiest data manipulation languages that you ever learn. So if I run this, it will give me only the records from that table where the closing price is greater than 999. So this is close because it's an alias. So what I'm doing now is I'm debugging. When you run into issues, you debug and then you correct it. The actual name of the column is close. I gave it an alias, closing price. So you see, as you see, this is showing me only 11 records where the stock price was greater than 999. So these are the dates when NVIDIA stock was above 999 or around $1,000. So I think the first instance was around this May 23rd, started from 1037 and then went all the way up to 1224, as you can see. So you can add conditions and you can add math in there as well. So let me paste that for you in the chat. I'm going to have you go in there and practice together in the next 30 minutes. Is it always set up? Yes, we already answered that. You can copy it. Now, the beautiful thing here is I can share this link with you. I can copy it. So if I go to share, I can share it, copy it, and then share that link with you. But let me not do that now. I want you to copy this SQL that I've pasted in the chat and then use it to share your screen, and we'll practice. We'll do some practice so that you build muscle memory around it. And once you build muscle memory around it, you get used to it. You practice over and over, you get used to it. And then eventually we'll keep moving forward. So as you can see, we haven't done this. We haven't done updates. We've seen the data which we've done. We've done a little bit of analysis and filtering. We've been able to add data, but we've not gotten to the part where we've removed data or update the data. We'll get that done. And pretty much we have done every possible action on a high level, at least, that we can do using SQL. The rest would be practice, practice, practice. You get used to it. We'll do aggregation, we'll do summations, we'll do counts, we'll do all kinds of functions that we can apply SQL with on given tables. So it's very important that you practice. So copy it before I let you share your screen, and then we'll take it from there.
I have a question.
Yeah, go ahead.
When creating a table, the data type, is the system going to suggest the data type or you just try it out?
You have to know. Of course, the system will suggest, but it makes sense. You know, within database, it will suggest. You will not always have database at your disposal, so you have to know what you're doing and then know what that column represents. So if the column says price, price is up to you. Is your price an integer price, or your price is a floating point price, or your price is a decimal? decimal floating points. Most likely your price will be decimal, right?
Okay.
So you will specify your data type as decimal, and that is what you would do.
Okay.
Yep. All right. Okay, so let's stop sharing, and that ends today's session, so you guys can share your screen and practice for me to see.